All right, I'm filming the review for the final exam bonus review. Question 1, the diameter of a circle has endpoints A and B. We're asked to find the equation and show all work. So remember that we need the center and the radius squared. So h comma k is our center. And those are the two things we need for the equation of the circle. So if those are the endpoints of our diameter, we know that the center has to be the midpoint. So I'm going to write M for midpoint. I guess I could have done C for center. A is at -5, 2. So remember these are x and y values. B is at -1, 0. So instead of going down by 2, I'm going to go down by 1 to find the number in the middle. And from A to B, instead of going up by 4, I'm going to go up by 2 to find the number in the middle. So our center is -3, 1. That's our H and our K. So then we already know x plus 4, oh sorry, oops, not 4, x plus 3 squared plus y minus 1 squared. So we already know that part of our equation. We need our radius squared. So if we plug in either of these endpoints into this equation, so if I do x plus 3 squared plus y minus 1 squared, that should give me my r squared. Our endpoints are both x and y values. So I'm going to use point B. You could use whichever one you want though. -1 plus 3 squared plus 0 minus 1 squared should give us r squared. -1 plus 3 is 2. 2 squared is 4. Write this out to the side. And then 0 plus -1, or 0 minus 1 is -1. -1 squared is +1. That should all equal our r squared. So we should get 5. So our final equation, I'm just going to rewrite that because it looks sloppy. X plus 3 squared plus y minus 1 squared, that equals 5. All right, for questions 2, you probably want to use your composite volume sheet. For the first one, in number 2, we have a cylinder with a cone attached. So the volume of a cylinder is area of the base, pi r squared times the height. The volume of a cone is 1/3 times area of the base, pi r squared times the height. So very similar formulas. So honestly, I'm going to do all of this work in my calculator, but I'm going to write it out first. So I'm going to do the cylinder, pi times my radius of 3 squared times the height of the cylinder. So the height of the cylinder is the distance between its bases. So its height is 7. I'm going to add to that the cone, which is 1/3 pi times my radius squared, same radius. And then the height of the cone is from its base to its top vertex, so times 4. I'm going to literally plug that all in my calculator. If you show me what you're going to plug in, that's helpful. So let's see, so we're going to do pi times 3 squared times 7 plus 1/3, I'm not really even sure you need the parentheses, pi times 3 squared times 4. So we get 235.619 approximately. And then that's in cubic inches. And if you were to leave that in terms of pi, if I just not put those pi's in there, that would have been 75 pi cubic inches. So either of those would be correct. Okay, let's take a look at the next one. We have a cylinder with a hemisphere on top. So the volume of the cylinder, again, is going to be pi r squared times the height. The volume of a hemisphere, we're going to have to take the volume of a sphere and divide it by 2. So the sphere is 4/3 pi r cubed, and we're gonna divide that by 2. And again, these basic formulas are on your formula sheet. You just need to know to divide by 2 if it's half a sphere. And then we'll add those two together. All right, I might just do these separate. So for my cylinder, it's gonna be pi. My diameter is 12 inches, so my radius is 6 inches. So 6 squared. The height of my cylinder is 13. And then for the volume of my hemisphere, my half sphere, that's gonna be my 4/3 times pi times the radius of 6 cubed, and then I'm gonna divide all of that by 2 since it's just half of a sphere. So again, I'm gonna let the calculator do all that work. Pi times 6 squared times 13 is the cylinder, plus, and the calculator knows the order of operations, I'm gonna do 4/3 pi times 6 cubed, and then I want it to divide all that stuff by 2. Oops, uh-oh. I don't want that 3/2 to be my exponent. There we go. All right, so for the volume of that composite shape, we get 1,922.655 cubic inches. And if you instead chose to do that in terms of pi, that should be 612 pi cubic inches. All right, last but not least, the third of number 2, I guess, 2C, if you will. I'm gonna just draw a line here. All right, so for this last one, we've got a cylinder and a rectangular prism. So for the cylinder, again, it's pi r squared h, area of the base times the height. For the prism, it's a length times width times height. So area of the base is length times width. All right, so for the cylinder, I'm gonna do pi times 4 squared times the height of 8, since the cylinder is 8 feet tall. For the prism, I'm just gonna do 14 times 8 times 12. So I'm gonna do this one separately, and I'll show you why. So pi times 4 squared times 8, so let's see. That's approximately 402.124. And if we left that in terms of pi, so if we never multiplied through, that'd be 128 pi. And then the other volume of the rectangular prism is 1,344. So if we write this as a decimal, we just add those up, and our final volume is 1,746 and 124 1/1000ths, and that's in cubic feet. If you left it in terms of pi though, because the prism doesn't have a pi in it, the rectangular prism, you would have to write it as an expression. So you'd have to write 128 pi plus 1,344, and then I'd maybe put that in parentheses and say cubic feet. I'd probably just go with the decimal. All right, and then problems 3 on will be in another video.